Okay, and so you can see that we have control of what angles are visible, and the angles have to do with the turning of the crankshaft, and the turning of the crankshaft works exactly like a normal crankshaft, and there's connecting arms to the pistons on the crankshaft, and this crankshaft has an indicator of where is the crankshaft, and you can see I have this little orange arrow is connected to the crankshaft, and it's at 360 degrees. So, and 360 degrees is the point that I chose to be straight up, and obviously there isn't going to be a motor that has this thing on it, but it helps one to keep themselves clear. For example, I've also put an arrow in here that shows which direction things are turning in, and the whole entire purpose of this is to keep everyone from getting confused. And this is a strange engine in the sense that not all the pistons are the same size from a diameter viewpoint, and they are not necessarily of the same size from a throw viewpoint. But the benefit of having it this way is that volumes that are important, for example, a volume necessary for compression of the air, is not the same volume as the volume that you need for combustion of the air. And then there's a supercharger where exhaust gases from the combustion chamber push down on this piston, and when they push down on this piston, that supplies the force that pushes up on this piston to compress the air. And all of these different chambers are of a slightly different size, and what happens is, if you want them all hooked together on the same crankshaft, then they have to be turning at the same RPM. And if they're turning at the same RPM and have different volumes, and you give them about the same throw, then the only thing that's left to vary is the diameter. And I wanted to create a type of crankshaft that people are pretty familiar with, and this is the crankshaft. And you can see that what I actually misstated myself. They do all have about the same throw. This distance here from the crankshaft down to the arm, the crank arm, that distance is the same on all of these different pistons. And so that's why all the pistons have different diameters, is because we're trying to have the same throw and the same RPM but different volumes. And the only thing that's left to alter, if you want to have the same throw and the same RPM, the only thing that's left to alter would be the diameter of the piston. I mean the diameter of the piston and the diameter of the chamber. So that's why you get this weird looking motor with different diameters of pistons in it. Okay, and of course you can see once again that we're at the 360 place, and I did try to draw in there a type of representation of gear structure where the axis of rotation of the crankshaft converts itself to a slower rotation by having gears of different sizes, and then this gear, which is rotating in this direction of rotation, needs to be converted to a gear that's rotating in this direction. So this, say for example, is rotating on the x-axis, and we want this to rotate on the y-axis, and this is nothing more than a beveled gear arrangement where the beveling of these two gears allows this gear to be turning in the x-axis and this gear to be turning on the y-axis. And the reason why this gear needs to turn on the y-axis is because that gear on the y-axis is driving the rotation of this valve, and it struck me just from a design viewpoint that a good place to put that valve is in this up-down configuration, sort of sitting here in the top of the motor with the valve in between the sets of pistons. So the crankshaft, again, let's see, here's X is this direction, so the crankshaft is going around in the X direction, and the valve control, or the gas flow control valve structure, is going around in the Y direction.